Now let us continue previous class with the previous class conic sections and special course. In continuation, construction of conic section study, conic section of ellipse. So in this chapter, in this class, we will see as early as construction of parabola and construction of hyperbola. In this, what are the methods are available and what are the in your syllabus you will learn by practice all. Now let us first one, construction of parabola. The various methods used to construction of parabola are discussed below. Rectangle method. There are 5 methods. This is the first method, rectangle method, and second one is parallelogram method, and third one is tangent method, fourth one is double ordinate method, fifth one is drawing tangents to parabola. Now let us, and also we will see some examples also. Now come to beginning. First one, construction of parabola. It is a rectangular method. In this, let us consider a problem. A bullet is fired from the ground, reaches a maximum height of 100 meters and falls the point of firing. Trace the path of bullet in a space. Select the scale of 1:1000. Now let us continue explanation rectangle method as previous. That is, first draw AB of 250 meters length, which is scaled as up to 25 centimeters. Now draw OV of 100 meters height bisecting AB at O. Construct the rectangle ABCD as shown in figure such that V lies in the mid of D. Divide AB into any number of equal parts, say 4 at 1, 2, 3, join V1, V2, V3. Divide AO into same number of equal parts 1, 1, 2, 1, 3, 1. So they intersect V1, V2, V3 at P1, P2, P3. Draw a smooth curve A1, P1, P2, P3. The same procedure can be repeated to the other half of the curve. The resulting curve is required parabola. Once again, first draw AB of 250 meters length, 25 centimeters in a scale. Draw OV of 100 meters height bisecting AB at O. Constructing the rectangle ABCD as shown in figure such that V lies in the mid of CD. Divide AD into any number of equal parts, say 4 at 1, 2, 3. Join V1, V2, V3. divide AO also into same number of equal points 1 1 2 1 3 1. Draw perpendicular AB to AB at 1 1 2 1 3 1 so that they intersect V1 V2 V3 at P1 P2 P3. Now let us draw smooth curve through A1 P1 P2 P3. Similarly, the procedure can be repeated to get the another half of the curve. This is the resulting curve is a required parabola. Now let us second method, that is parallelogram method. As previous, let us construct the parallelogram ABCD shown in figure and mark the point O, that is midpoint of DC and AB respectively. Connect V1, V2, V3 and divide AO also into the same number of 4 equal parts at V11, 21, 31. Draw parallel to AD at 11, 21, 31 to intersect P1, V2, V3 at P1, P2, P3. Join A, P1, P2, P3 by smooth curve. As the previous example, the same procedure can be repeated, get the one half of the curve. This results curve of required parabola. Now method 3, tangential method. Here the bullet is fired from ground level at the inclination of 60 to the ground, which is assumed to the horizontal. The shot returns to the ground at a 0.8 meter distance from the point of firing. Trace the path of bullet. A scale of 1,000 may be used. Now let's draw AB is equal to 80 meters. Construct an equilateral triangle ABC with 60 degrees to base angle and base AB. Draw CO perpendicular to AB. Bisect CO at B, the vertex. Divide AC and BC into the same number of equal parts, say 6. Name the division points on AC and BC in the order opposite to each other as shown in figure. Join the division points 1, 1 dash and 2, 2 dash and so on. Now starting the curve from point A, draw the curve tangential to these lines. This will result the required parabola. Once again, draw AB equal to 80 meters. Construct an ellipse equilateral triangle ABC with 60 degrees as a base, angles and base as AB. Draw CO perpendicular to AB. Bisect CO at B, the vertex. Divide AC and BC into same number of equal parts, say 6. Name the division points AC and BC in order to opposite each other as shown in figure. That is 1, 2, 3, 4, 5. To on AC, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash on CB. Join the divisions 1, 1 dash and 2, 2 dash and so on. Now starting curve from A, draw curve tangential to these lines, which will result the parabola. This is the tangential method. And now double ordinate method, in which draw a parabola given its double ordinate and abscissa as 75 mm and 40 mm respectively. Let us construct ABCD with sides of 75 mm and 40 mm such that B lies in the mid of CD as shown in figure. Divide AD into any number of equal parts, say 4 at 1, 2 and 3, join V1, V2, V3. Divide AO also into same number of equal parts at 1, 1, 2, 1, 3, 1. Draw perpendicular to AB at 1, 1, 2, 1, 3, 1 so that they intersect V1, V2, V3 etc. at P1, P2, P3. Draw a smooth curve through A, P1, P2, P3. The same procedure can be repeated to get the other half of the curve. Now we will get the required parabola. Observe all. This is the double ordinate method. Abscissa. This side is abscissa and this is the double ordinate. The XX, just like XX, not XX. This is method 4, double ordinate, and method 5, draw tangents to parabola.
Drawing tangents to parabola. Tangents to parabola may be drawn either through or at a point on the curve itself or from a point lying outside the curve. There are two methods available for drawing a tangent: through or at a point on the curve itself and from points lying outside the curve. Point on the curve. Method 1. When the position of focus and directrix are known. Problem number 14. Draw the parabola when the distance of the focus from the directrix is 45 millimeters and eccentricity is 1, as in problem number 1. Draw the normal and the tangent to the parabola at a point lying on the curve 30 millimeters from its vertex. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Join P and F and draw line PM perpendicular to the directrix. Bisect the angle MPF and the bisector PQ will be the required tangent. The line PM drawn perpendicular to the tangent at P is the normal. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Point on the curve. Method 1. When the position of focus and directrix are known. Problem number 14. Draw the parabola when the distance of the focus from the directrix is 45 millimeters and eccentricity is 1, as in problem number 1. Draw the normal and the tangent to the parabola at a point lying on the curve 30 millimeters from its vertex. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Join P and F and draw line PM perpendicular to the directrix. Bisect the angle MPF and the bisector PQ will be the required tangent. The line PM drawn perpendicular to the tangent at P is the normal. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Join P and F and draw line PM perpendicular to the directrix. The line PM drawn perpendicular to the tangent at P is the normal. Locate the point P by cutting an arc with V as center and 30 millimeters as radius. Method 2. When the focus and directrix are not given. Problem number 15. Draw a tangent at a point on the curve 40 millimeters from its vertex. Locate the point P on the curve by cutting an arc with V as center and 40 millimeters as radius. perpendicular PP1 cuts the axis at A. Mark the point T by measuring VT is equal to VA on the axis. Connect TP and produce. TS is the required tangent.
Once again,
locate the point P on the curve by cutting an arc with V as center and 40 millimeters as radius. Draw the line PP1 perpendicular to the axis from P. The perpendicular PP1 cuts the axis at A. Mark the point T by measuring VT is equal to VA on the axis. Connect TP and produce. TS is the required tangent. Locate the point P on the curve by cutting an arc with V as center and 40 millimeters as radius. Point outside the curve. Problem number 16. For the same problem given in method 1, draw a tangent to the parabola from a point lying outside the curve 20 millimeters and 25 millimeters from the vertex and focus respectively. Point outside the curve. Problem number 16. For the same problem given in method 1, draw a tangent to the parabola from a point lying outside the curve 20 millimeters and 25 millimeters from the vertex and focus respectively. Locate the point P outside the curve as follows. Take 25 millimeters radius and S as center, cut an arc between the vertex and directrix as shown in figure. Take 20 millimeter radius and V as center, cut an arc intersecting the previously drawn arc at P. With P as center and radius PS, draw an arc to cut the directrix at A and B. Draw perpendicular lines from the directrix to cut the parabola at T and T1. Join P and T and extend, and similarly join P and T1 and extend. The above lines are the required tangents.
Once again,
locate the point P outside the curve as follows. Take 25 millimeters radius and S as center, cut an arc between the vertex and directrix as shown in figure. Take 20 millimeter radius and V as center, cut an arc intersecting the previously drawn arc at P. With P as center and radius PS, draw an arc to cut the directrix at A and B. Draw perpendicular lines from the directrix to cut the parabola at T and T1. Join P and T and extend, and similarly join P and T1 and extend. The above lines are the required tangents.
Now these are all the parabola constructions. Now next, construction of hyperbola. In this, the various methods used to constructing hyperbola as follows. Method 1. Constructing hyperbola when the distance between construction of hyperbola. Method 1. Construction of hyperbola when the distance between foci and length of the transverse axis are given. Problem number 17. Draw a pair of hyperbola and the distance between the focus foci 100 mm and the length of the transverse axis is 70 mm. Find the eccentricity of the curve. Now let us observe how we will construct a hyperbola. Draw AB equal to the transverse axis and produce it on either side. Mark F1, F2 are equal to the distance between the focus OC. On BA, produce mark number of points 1, 2, 3, etc. arbitrarily. On AB, produce mark number of points 1 dash, 2 dash, 3 dash, etc. of the same distance as 1, 2, 3. With A1 as radius F1 as center, draw the first set of two arcs. With B1 as radius F2 as center, draw arcs to cut previous arcs at P1 and P1 dash. With the same radius B1 and F1 as center, intersect the second set of two arcs drawn with the center F2 and radius B1 dash at Q1 and Q1 dash. Repeat the procedure for the other points 2, 3, etc. Now join these 2 points and obtain a smooth curve. To find eccentricity, first directrix is located. To find directrix, draw F1C perpendicular to the axis. Draw the bisector of F1, CF2. The bisector will intersect the transverse axis at D. At D, draw perpendicular to the transverse axis AB, which will be the directrix. Draw CE perpendicular to the directrix. The eccentricity is the ratio of CF1 and CE. Now once again, draw AB equal to transverse the axis and produce it on either side. Mark F1, F2 equal to the distance between the foci. On BA, produce mark number of points 1, 2, 3, etc. arbitrarily. On AB, produce mark number of points 1 dash, 2 dash, 3 dash, etc. of the same distance as 1, 2, 3. With A1 as radius F1 as center, draw the first set of two arcs. Similarly, with B1 as center, F2 as a center, draw arcs to cut the previous arcs at P1 and P1 dash. With the same radius B1 and F1 as center, intersect the second set of two arcs drawn with the center F2 and radius B1 dash at Q1 and Q1 dash. Repeat the procedure for the other points 2, 3, etc. Join these points and obtain a smooth curve. To find eccentricity, first First, the directrix is to be located. To find directrix, draw F1C perpendicular to the axis. Draw the bisector of F1, C, F2. The bisector will intersect the transverse axis at D. At D, draw perpendicular to the transverse axis AB, which will be the directrix. Draw CE perpendicular to the directrix. The eccentricity is ratio of CF1 and CE. Now construction of hyperbola. In this construction of hyperbola, there are various methods are used. The distance between OC and length of the transverse axis are given. Problem number 17. Draw a pair of hyperbola. The distance between OC 100 mm and length of transverse axis is 70 mm. Find the eccentricity of curve. Draw AB equal to the transverse axis and produce it on either side. Mark F1, F2 equal to the distance between the foci. On BA produce mark number of points 1, 2, 3, etc. Arbitrarily produced mark number of points 1 dash, 2 dash, 3 dash, etc. of the same distance as 1, 2, 3. With A1 as radius and F1 as center, draw the first set of two arcs. With B1 as radius, F2 as center, draw arcs to cut previous arcs at P1 and P1 dash. With the same arcs, with the same radius B1 and F1 as center, intersect second set of two arcs drawn with the center F2 and radius B1 dash at Q and Q1 dash. Repeat the procedure for the other 2 points, 2, 3, etc. Join these points with obtain smooth curve. To find the eccentricity first directrix to be located. To find the directrix, draw F1C perpendicular to the axis. Draw the bisector of F1, C, F2. The bisector will intersect the transverse axis at D. At D, draw perpendicular to the transverse axis AB, which will be the directrix. Draw CE perpendicular to the directrix. Eccentricity is the ratio of CF1 and CE. Now next method, constructing hyperbola when abscissa ordinate and half transverse axis are given. Problem number 18. Draw hyperbola when half of the traverse axis 100 mm, the abscissa is 70 mm and the double ordinate is 160 mm. Let us draw OB equal to half of traverse axis. Let V equal to abscissa BC, the double ordinate. Complete the rectangle ABCD as shown in figure. Divide C into number of equal parts, say 4, and name them as 1, 2, 3. Join O1, O2, O3. Divide CD also into the same number of equal parts. Connect V1 dash, V2 dash and V3 dash. These lines will intersect O1, O2, O3 at P1, P2, P3, etc. Join V1, P1, P2, P3 and so on by smooth curve. Similar, draw the other half of the curve. This is the half traverse axis method by constructing a hyperbola. Now the method 2, 3, the asymptotes and the points on curve is given. Problem number 19. Asymptotes of hyperbola are inclined at angle 75 degrees to each other. A point P on the curve is at a distance 30 mm and 25 mm from asymptotes. Draw the hyperbola passing through the point P. Find the eccentricity of the curve. Once again, draw the asymptotes OX, OA at the given angle, say 75 degrees. Asymptotes. Mark the point P, 30 mm and 25 mm from asymptotes. To P, draw the lines AB and CD parallel to OX and OY respectively. Draw number of radial lines through O to cut EA at 1, 2, 3, etc. and PD at 1 dash, 2 dash, 3 dash, etc. Through 1 dash, draw a line parallel to OX and through 1, draw a line parallel to OY to intersect each other at P1. Similar, obtain P1, P2, P3, etc. Join P1, P2, P3 and P by a smooth curve. Now draw number of radial lines from O to cut PB at 4 dash, 5 dash, etc. and PC at 4, 5 and so on. Through 4, draw a line parallel to OX to cut through O dash. Draw a line parallel to OY to intersect each other at P4. Similarly, obtain other points P5. point P5, etc. Draw a smooth curve through P, P4, P5 and so on. Method 4. Draw rectangular hyperbola through a given point P. Problem number 20. Draw a rectangular hyperbola through a given point P on it at a distance of 25 mm and 20 mm from the two asymptotes. Draw OX and OY, the two asymptotes perpendicular to each other. Mark the point P, draw AB and CD parallel to OX and OY respectively 25 mm, 20 mm apart from asymptotes. Draw number of radial lines through P to cut PD at 1, 2, 3 and PB at 1 dash, 2 dash, 3 dash and so on. Draw the parallel vertical line through 1 dash and horizontal line through 1. Both will intersect at point P1. Similarly, for each of the other radial lines, obtain the points P2, P3 and so on. Connect P1, P2, P3 and so on by smooth curve. Now draw radial lines from O to cut OA at O5 and PC at 4 dash, 5 dash. Draw horizontal line through 4 dash and vertical line through 4 to get P4. Similarly, obtain other points P5. Join P, P4, P5 and so on by smooth curve as shown in figure to get the required hyperbola. Drawing tangents to hyperbola.
Drawing tangents to hyperbola. Tangents to hyperbola may be drawn either at a point on the hyperbola or from a point outside it. Method 1. Drawing a tangent at a point on the curve. Problem number 21. Construct the hyperbola given in problem 1 and draw a tangent through a point on it, 50 mm from the vertex. Draw the curve as explained in problem 1. Let S be the focus and mark point P on the curve through which the tangent is to be drawn. Connect P to S. At S, draw a line perpendicular to PF to intersect the directrix at T. Connect T to P and extend it. TA is the required tangent. Method 2. Drawing the tangent from a point outside the curve. Problem number 22. Draw a hyperbola given in problem 21. Draw a tangent to the hyperbola from a point P lying outside the curve 45 mm and 35 mm from the vertices. Construct the hyperbola as given in problem 21. such that it is 45 millimeters and 35 millimeters from the two vertices A and B respectively. Connect P to the nearest focus, say F1. Draw a circle with the transverse axis as diameter. Draw a circle with PF1 as diameter. Let both the circles intersect at E and E1 as shown in figure. Join F1, E and extend it. Mark C on set F1E extended line such that EC is equal to EF1. Join F2C and extend it to meet the curve at T. Join P and T and extend it to D. PD is the required tangent.
Once again.
Construct the hyperbola as given in problem 21. Locate the point P such that it is 45 millimeters and 35 millimeters from the two vertices A and B respectively. Connect P to the nearest focus, say F1. Draw a circle with the transverse axis as diameter. Draw a circle with PF1 as diameter. Let both the circles intersect at E and E1 as shown in figure. Join F1, E and extend it. Mark C on set F1E extended line such that EC is equal to EF1. Join F2C and extend it to meet the curve at T. Join P and T and extend it to D. PD is the required tangent.
This is the end of the construction of parabola and hyperbola. At this time, we will close the conic sections and the special curves. In that, first construction of the conics and construction of ellipse and construction of parabola and construction of hyperbola is completed now. So this is the end of the class.